All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna continue learning about Godot. Today's stream might only be for I don't know an hour, and that's completely on me because I really needed a nap before the stream, and what was supposed to be a 20-minute nap ended up being an hour and 20 minutes. And so I became a little bit late to stream. Hopefully, we are able to get at least at least an hour's worth of stream in today. I'm gonna try and keep my usual like initial yapping to the minimum. Um, Something that I do wanna yap about is this thing. So I was mentioning yesterday. Hold on, there might be like a bit of a um, what should I call it? Screen flash. Just a bit of a bright color showing up on stream. Basically this. It's not that bright, but like you know, just felt like I should give a warning. Um, this is uh, this is graphics being drawn through the terminal cells. So if I come here and try to select these, you can see I'm able to select this. I can also select a block like this. Yeah. So these are terminal graphics. Speaking of the terminal, I need to switch to this one. Yeah. Okay. So I spent today and most of yesterday as well, I think, doing research on how to um, how to do what. What was I trying to do? Um, oh yeah, I was trying to do research because, dude, okay, I after doing research and reading up on the various libraries that are available and what they can do and stuff like that. It dawned on me that the specific thing that I am trying to do, I would actually need to like look for a library that does that specifically. Specifically, what I'm looking for in this case is a 2D graphics library that mainly only does well, of course, it does the 2D graphics, like the drawing part, creating a structure that uh, resembles like a circle, for example, and also creating a structure that resembles a grid, and then drawing this circle onto the grid. However, stopping at that point, as in rasterizing the shapes, and placing them within the grid of pixels, but like we stop at that point. What I'm looking for is a library that basically stops at the rasterization point, um, to where it is able to give you this grid of pixels that you can then do your own transformations on. I don't want a library that actually draws it to the screen. I need a library that just stores it into a buffer and then hands me that buffer of bytes, representing a 2D grid of pixels, so I can then do whatever I want with that. And I can the closest thing that I've come up with for this is 2D software rasterization libraries. Like, I'm not even sure what I'm supposed to be Googling for this. It just so happened that fortunately I started doing my research through Gemini in terms of what I should be using for this purpose. And so I came across Tiny Skia. Um, there were a couple of others that I came across as well. And when I did, well, okay, there were a couple of others that were suggested by Gemini, like two or three others. And other than that, I also chose to do my own research to see if I can find something better or just some other alternative that maybe Gemini didn't didn't know about, and I didn't, I didn't find another Gemini, another alternative, because again, my situation is kind of special because, give me a second. Yeah, sorry, my eye was itching, so I was just rubbing it. Okay, yeah. What was I saying? Yeah, my situation is kind of special because again, what I need is I need a 2D graphics library that stops at the rasterization step. It doesn't actually render the entire image to, or, well, I feel like the terms rasterization and rendering, sometimes they can kind of be used interchangeably, or rather, um, some people might call, um, they might call the act of storing the rasterized image into a buffer rendering. They might call that rendering as well, and then they'll call the displaying it on the monitor rendering as well. In my case, when I say rendering, I mean like displaying it on the monitor within like the window, and I'm not looking for any of that. I'm looking for it to stop at the rasterization step. So we have a grid of a 2D grid of pixels being represented as bytes. So we have RGBA values for every single pixel in the grid. So if it's a 100 by 100 grid, and there's supposed to be four bytes per pixel in the grid. So 100 by 100 would be, what is that, 10,000? Yeah, four zeros, right? Yeah. So 100 by 100 would be 10,000. And then because each pixel out of those 10,000 pixels, each pixel is supposed to have 4 bytes for R, G, B, and A. So it's going to be 40,000. Why was I talking about the total? I forgot why I was talking about it. But yeah, okay. What I'm looking for is a library that'll do all of the drawing up to the rasterization part, and then it'll just hand me that buffer so I can do whatever I want with it. The thing is, if I this what I'm looking for is mostly only possible with CPU rasterization libraries, because um, libraries that do GPU based rasterization, they tend to be set up in a very different way. They tend to be very tightly coupled with GPU technology, just for the sake of doing things more efficiently. So a lot of the functions that you're going to be calling, they tend to be like they're operating under the assumption that you will be sending this data to the GPU eventually. So if you are looking for something that's meant to work on the CPU, then you should look for a CPU based rasterizer, or I guess a software rasterizer. Um, it comes under that. I think software renderer might also come under that. I think so. I think software renderer also comes under that. But yeah, okay. Okay, see, I said that I wasn't gonna get distracted with a yap session about this, and I ended up getting distracted. Give me a second. Let me open up my stream on my phone. More specifically, open up my chat on my phone. And then we're going to continue. We're going to continue learning Godot. By the way, this is some of the code of this thing that I was doing. More specifically, testing. Actually, I wasn't. I haven't done stuff with Tiny Skia yet. So far, the only Tiny Skia related thing that I'm using is this, where I've created a pix map, which is it's a structure that's supposed to represent this this your entire well, pixel map, your entire like 2D grid, but it stores a bunch of extra information as well. And also through this structure, you can manipulate this 2D grid. And I'm fortunate enough that I came across this library. Another alternative to this would have been embedded graphics, which is a graphics crate for embedded devices. The problem with that would have been that a lot of times that crate and like the functionality in that crate, it's not aimed at at like high power computing devices. It's aimed at uh, low power devices like microcontrollers. That is why you would be using this with something like the ESP32, for example. Um, so as a result of that, I probably wouldn't be, I probably wouldn't have been dealing with floating point operations. I would have been dealing with integers. And I don't know if that's going to like, in terms of the rendering quality or the rasterization quality, I should say, I don't know if that would have affected the quality negatively. Because here's the thing, right? Anything that's being done 2D graphics wise, I want to allow the library to do its own thing up until the rasterization point. And this is like, I lucked out. I hit the jackpot right at the beginning. Even though I continued looking, I had hit the jackpot right at the beginning. I found exactly what I was looking for. What I was looking for, again, is a 2D graphics library in which I can make function calls to draw shapes onto onto a pixel grid, and then rasterize that entire thing, rasterize like all of the shapes that I'm drawing into one pixel grid image sort of thing, but only have that pixel grid being represented as a data structure rather than actually being rendered. That's exactly what I was looking for, and Tiny Skia apparently does just that. It does exactly that. I don't know if Tiny Skia does have any rendering capabilities, but I even if it does, I don't need those capabilities. All of the other stuff that it does, I definitely need all of that. So like creating a pixel grid, being able to work with path builder objects to create various shapes, being able to, there's something shader related. I'm gonna have to look into what that does. There's a lot of like convenience functions, utility functions, and all. A lot of interesting stuff that allows you to draw things onto the pixel grid. And after this pixel grid has been prepared, the next thing I need to do is write a translation layer that converts this grid of pixels into into terminal ASCII codes, terminal ANSI codes, um, or what are they called? ANSI code sequences. That's exactly what it's called. These are essentially um, sequences like, hold on, I can show you. Sequences like these that change the internal state of the terminal itself, and they are used to do various types of interesting things with terminals. In my specific case, the interesting thing that I'm trying to do is change its graphics capabilities, change things rendering wise. So specifically, what I'm trying to do is change the foreground color and change the background color. So there are two separate uh, ANSI code sequences for that. And yeah, this is how you can print out cells of different foreground and background colors. And for situations where so okay, in a terminal, if you pay attention to the cursor right now, you'll notice that the cursor is actually okay. Not just the cursor. I can show you in this. So if you look at the, man, this color is a little too bright to look at. I mean, it's a really nice color. That's why I went for this color. But like as like a block, it's a little bright to look at. Um, well, I could, okay, I'm trying to show, well, yeah, okay. So if you look at the cursor right now, wherever the cursor is, you'll notice that it's not a square. It's a rectangle. And so anything that I'm drawing, it's basically me filling in a rectangular cell, a rectangular grid cell, not a square cell. So anything that I'm drawing is gonna have like that elongated kind of quality. If I try to draw a circle, it's not gonna be a circle, it's gonna be an oval. And so, you know, a lot of uh, a lot of drawing stuff is gonna be negatively impacted by that. To kind of mitigate that issue, I can use this half block character instead of the full block character. What I'm using here is a full block. Instead of that, I could use a half block character. And the trick here is you have the half block character, so it's only occupying half of the cell in the foreground. So when you set the foreground color, you're setting the color for that square. And on that same cell on which you're printing this half block, if you set the background color to something else, you now have two separate colors. So these two can be treated as two separate cells. There's a bit of math involved there that I'm going to have to look into. I'll get there at some point. For now, what I wanted to do is find a simple way to print out um, print out graphics to the terminal, specifically print out ASCII graphics to the terminal. Well, this isn't exactly ASCII graphics. This is more ANSI graphics, if that's even a thing, because we're using ANSI control, uh, ANSI code sequences to change the state of the terminal and um, to quote unquote draw stuff in the terminal. Dude, I keep getting distracted. We are like 17 minutes into the stream. We are also dropping frames, so give me a second here. I'm gonna try and mitigate that issue. Hopefully put a much lower load on the system, or no, on, well, the internet connection specifically. Okay, I think we should be good. Right. So, yeah, I've been busy with this. I've been doing a bunch of this stuff off stream, and I'm going to continue doing this off stream even after today's stream because I'm slowly exploring tiny Skia and drawing stuff. This is just a tiny bit of rendering code that I had written where I'm setting the foreground color. Basically, I'm generating like a very long sequence. Can I hold on? Oh, I won't be able to print it out. Yeah, I won't be able to print it out because the string itself. So okay, buff string here, buff str is actually a very long, and this is what I was like experimenting with because I wanted to see if it's possible for me to squeeze everything into one string, and it turns out that that is actually a very common thing to do, squeezing the entire thing into one string rather than having separate print line calls for every single cell. Believe it or not, that initially that was what I was trying to do. I was that's what I was considering doing, having like a separate print line call for setting the foreground color, then having a separate print line call um, for printing the printable character, the full block, and then the whole thing just repeats again and again for every single cell. And with the number of method calls, holy shit, I can't imagine how slow that would have been. Though, I mean, to be fair, this is a small grid. It's not a very big grid. Another thing I kind of want to look into, if you notice here, this is currently a rectangle, right? This is actually a 25 by 25 pixel map that's being rendered. And this kind of shows you what I was talking about, that, you get like an elongated sort of um, rendering. You basically get an elongated sort of shape, even if you initially described it um, as a square, you get this kind of shape. So I need to use that that whatever that algorithm is called to basically um, use one cell for 2 pixels. Okay, all right. Um, I really should step away from this thing and get back to learning Godot. Otherwise, we are not going to make any progress. We are now 20 minutes into today's stream, which is a stream which is probably only words, a stream which is probably only going to be an hour long. We are already 20 minutes into that stream. Okay, so we're gonna start with this. Give me a second here. Okay. Um, yeah. So step by step, this series builds upon the introduction to Godot and will get you started with the editor and the engine. You will learn you will learn more about nodes and scenes, code your first classes with GDScript, which in our case, we're going to be coding it in Rust because once we get to this part, creating your first script, once we get to this part, we have to switch over to the Rust hello world thing, which is this one. Hold on, I need to set that thing up for loading. But yeah, we're going to be switching over to that and doing both creating your first script on like the Godot engine page. We're going to have that page open, and we're also going to have the Rust, the Godot Rust page open, so we can do both of them side by side. Basically, learning how to do scripting stuff in Godot, but learning it through Rust, learning how to do it through Rust. For now, though, we still have a tiny bit of reading to do. So I'm guessing it's not going to be for another 1 or 2 streams that we start the scripting, because we have a bunch of this reading stuff and probably a bunch of like practical stuff to do within the Godot editor, because it's not just scripting. There's a bunch of extra stuff that we have to look into as well, right? There's a lot of like editor editor centric, I guess is a good way to put it. There's a bunch of editor centric stuff that we have to learn as well. Anyways, okay. This series builds upon the introduction to Godot and will get you started with the editor and the engine. You will learn more about nodes and scenes, code your first classes with GDScript, use signals um, to make nodes communicate with one another, and more. The following lessons are here to prepare you for your first 2D game. Okay, a step-by-step tutorial where you will code a game from scratch. You know what? This time around, we might actually be able to go through that tutorial as well. I am going to be honest, I don't know if I'm going to have the patience for that, because I have the tendency to just wander off on my own if the tutorial that I'm going through is not keeping me engaged enough. It's not stimulating enough for my brain, and I start getting distracted with other stuff. I just kind of make my own. I create my own path, and I'm like, okay, I'm gonna explore the engine in this way. And I mean, to be fair, that is a completely valid method of learning as well. Um, it has worked for me in various situations. It's a messy method, but considering how my brain works, it's a valid method, and it's a method that works. It's a method that has worked for me. Okay, all right. The following lessons are here to prepare you for your first 2D game, a step-by-step tutorial where you will code a game from scratch. By the end of it, you will have the necessary foundations to explore more features in other sections. We also included links to pages that cover a given topic in depth where appropriate. Awesome. Okay, so nodes and scenes. In overview of Godot's key concepts, we saw that a Godot game is a tree of scenes. Oh, or just hold on. Oh, I guess the page wasn't done loading. Okay. We saw that a Godot game is a tree of scenes, and that each scene is a tree of nodes. A Godot game is a tree of scenes, and each scene is a tree of nodes. Okay, yeah, that makes sense. Each scene is a tree of nodes, and each of those nodes themselves could actually be a separate scene. Um, yeah, okay. In this lesson, we explain a bit more about them. You will also create your first scene. Okay, nodes. Nodes are the fundamental building blocks of your game. They're like ingredients in a recipe. They're like the ingredients in a recipe. There are dozens of kinds. Hold on. I don't know why that tripped me up. There are dozens of kinds that can display an image, play a sound, represent a camera, and much worse. Much worse. What? Why did? Why did I read that as much worse? Much. Hold on. What just happened? Much, much more. What was I thinking that made me say much worse? Anyways, okay. There are dozens of kinds that can display an image, play a sound, represent a camera, and much more. Um, right. Okay. Cool. All nodes. Wait. Oh, did they say something about functionality? Okay, they're going with like an analogy. Okay, all right. All nodes have the following characteristics. They have a name, editable properties. They receive callbacks to update every frame. Okay. You can extend them with new properties and functions. Okay, that's, yeah, okay, hold up. That is something we need to explore. Extending an existing node's functionality with new properties and functions. Because I know we can create custom nodes. Actually, no, hold on. Generally, the idea behind scripting in Godot is that you create a script and then you attach the script to this script property that every node has. So every node gives you uh, this field, this script field that you can attach a script in or put a script in. And yeah, this is how you I guess this is how you extend the node's functionality. You This is how you give it extra properties and functions. And because because the script is attached to this node, so you're probably also going to have access to this specific node's very specific type of functionality. So for example, if it's a sprite 2D, then you'll most likely have access to like the very specific sprite 2D functionality. I don't remember exactly because I haven't done Godot scripting in a while, but I mean we're going to be exploring that really soon, so I guess we'll find out. Okay. Right. They receive, okay, you can extend, okay, you can add them to another node as a child. All right. The last characteristic is important. Together, nodes form a tree, which is a powerful feature to organize projects. Since different nodes have different functions, combining them produces more complex behavior. As we saw before, I'm as I'm learning more about Godot, I'm I keep thinking back when I was doing Unity stuff more regularly, and I would talk about Godot. I didn't know anything about Godot at the time. I was just kind of repeating what I'd heard other people saying, other people who had used Godot. I'd heard them saying that, oh, you know what, Unity is game object based, and um, Godot is node based. So where in Unity you have game objects and components, in Godot you have nodes to create different types of functionality. I didn't understand what that meant practically because I had never actually done that. I'd never actually um, used Godot. I hadn't actually used the node functionality in order to know exactly what it meant for the engine to use nodes. Give me a second here. Okay. Right. Together, nodes form a tree, which is a powerful feature to organize projects. Since different nodes have different functions, combining them produces more complex behavior. As we saw before, you can build a playable character. Um, the camera follows using character body 2D, sprite 2D, camera 2D, and collision shape 2D nodes. Okay, all right. Scenes. When you organize nodes in a tree, like our character, we call this construct a scene. Once saved, scenes work like a new scenes work like new node types in the editor, where you can add them as a child of an existing node. In that case, the instance of the scene appears as a single node with its internals hidden. Scenes allow you to structure your game's code however you want. You can compose nodes to create custom and complex node types, like a game character that runs and jumps, a life bar, a chest with which you can interact, and more. Okay, the Godot editor essentially is a scene editor. It has plenty of tools for editing 2D and 3D scenes, as well as user interfaces. A Godot project can contain as many scenes as you need. The engine only requires one as your application's main scene. This is the scene Godot will first load when you or a player runs the game. Okay, on top of acting like nodes, scenes have the following characteristics. They always have one root node, like the player in our example. You can save them to your local drive and load them later. You can create as many instances of a scene as you'd like. You could have five of you wait. You can create as many instances of a scene as you'd like. You could have five or ten charac- 5 or 10 characters in your game created from your character scene. Okay, creating your first scene. Let's create our first scene with a single node. To do so, you will need to create a new project first. After opening the project, you should see an empty editor. Okay, so we don't have an empty project yet. I don't think we need to create an empty project. Hold on, I am curious about what would happen if I deleted this node that's currently open. What is that? Oh God, I can't read this. Removing the selected files. Removing the selected files from the project. Oh God, this is so small, dude. I need to start using Godot on my like directly on this laptop as opposed to uh, running it on a different system and then looking at the RTMP feed. Actually, I'm not even looking at the RTMP feed. I'm looking at the Godot editor itself, but this screen is so small that um, the resolution, the max res, is not all that much. It's, I think, maybe 1366 by 768, whereas the laptop that I'm currently streaming from it supports a max res. I'm pretty sure, because of the monitor as well as the laptop's capabilities, but the monitor itself has to support that resolution, at least from my understanding. Um, yeah, this monitor that I'm using, it supports 1920 by 1080, so I can see a lot more, even if I zoom in. Anyways, okay, let's try to read this. Depending on your file system configuration, the files will either be moved to the system trash or deleted permanently. Okay. Okay, so I deleted this. Oh, okay. So in that case, all it does is create this asterisk kind of thing. And now if I close this, scene so and so has unsaved changes, last saved 54 minutes ago. That's an interesting number. 54 minutes ago. I was not using this an hour ago. I did open I did open the editor probably an hour ago, I think. Yeah, don't save. And yeah, we can delete these as well. They're not necessary, they're not required. We can close this, don't save, and now we have our project in a clean state. Okay, all right. To do so, you will need to create a new project first. After opening the project, you should see an empty editor. All right. In an empty scene, the scene dock on the left shows several options to add a root node quickly. 2D scene adds a node 2D node. 3D scene adds a node 3D node. The user interface adds a control. Sorry, and user interface adds a control node. These presets are here for convenience. They are not mandatory. That is good to know, actually. Okay, other node is is equivalent to pressing the add child node button at the top of the scene dock, which holy shit, what is up with my voice? Which usually adds a new node as a child of the currently selected node. You know what? Let's try that. Let's try that. Oh, this is interesting. So we are starting by adding a label. Let's do that. Okay, what I was gonna do was I was gonna select this or try to create this, just to, demonstrate creating a 2D scene using this button versus creating a node 2D here, because clicking 2D scene is just gonna create a node 2D, right? And that's exactly what happens here. So further from this point, I can then add child nodes to this. This is the root node. I wonder if we can have multiple root nodes though. What happens if I create another node 2D? That becomes a child. Let's say I'm not selecting. Oh, okay. Yeah. Okay. So there's only one root node. Okay. Let's stick with the tutorial and yeah. Give me a second here. Okay. All right. Um. Okay. Press the add child node button. I'm assuming they mean here. Yeah. Add child node or other node to create a root node. Awesome. To create a root node, no, the create the words, the create new node dialog appears, showing the long list of available nodes. Okay, select the label node. You can type its name or filter down the list. Is that going to be under control? Yeah, it's under control. Or I can filter it. Okay. All right. Click on the label node and click on the label node to select it, and click the create button at the bottom of the window. Okay. All right. A lot happens when you add a scene's first node. Okay, hold on. Let's add the first node first. Great. The scene changes to the 2D workspace because label is a 2D node type. The scene changes to the 2D workspace because, oh, 2D workspace. Okay, yeah, the workspace. I just remembered. Okay. 2D workspace because label is a 2D node type. Yeah, I have noticed this. If you have 2D and 3D scenes together in one node tree, then depending on which type of node you have currently selected, the editor automatically switches workspaces to the appropriate workspace. Okay, the scene changes to the 2D workspace because label is a 2D node type. The label appears. Select. Oh God. Okay. All right. The label appears selected in the top left corner of the viewport. The node appears. Wait, the label appears selected in the top left corner of the viewport. Okay. All right. Of the viewport. This is a viewport. It's not talking about the scene dock. It's talking about this. And and yeah, yeah. So this is in the top left corner of the viewport. Uh, the node appears in the dock. The node appears in the scene. Oh, okay, okay. Moving on. The node appears in the scene dock on the left, and the node's properties appear in the inspector on the right. So I need to remember that these things are called docks. Um, I I think I've even forgotten what they used to be called uh in Unity. I think it was I think they were just called panels. Yeah, I think so. I don't remember. But yeah, okay. I was worried that I might be confusing the terminology, but turns out I don't even remember the terminology. So never mind. We are good. Um okay. Changing a node's properties. The next step is to change the label's text property. Let's change it to hello world. Head to the inspector dock on the right of the viewport. Click inside the field below the text property and type hello. Okay, no, hello world. Okay, done. All right. What's next? You will see the text draw in the viewport as you type. Okay. You can edit any property listed in the inspector, as we did with the text. Wait, you can edit any property listed in the inspector as we did with the text. Oh, with this text. Okay, okay. For a complete reference of the inspector doc, see inspector doc. I think I'll do that off stream though. I'm gonna open up the page and look into it later. Um, you can move your label node in the viewport by selecting the move tool. Yeah, I need to figure out what the key, what the shortcuts are for this. Because in Unity we had like the QWERTY keys to switch between like transform tools and stuff. Um, okay, W is, oh wait, I'm still in the text thing. Let's move the cursor out of that, and now let's see. Okay, so Q is select. Fortunately, I think the QWERTY thing applies here as well, or at least up to quer. So Q is select, or what is it called? Select mode. W is move mode, and then rotate is E, or rotate mode, I guess, is E, and R is scale mode. Great, awesome. So what does it say? With the label selected, click and drag anywhere in the viewport. Oh, you know what? This is useful. I have not done this before, because what I'm used to is, oh God, it recorded a bunch of these movements. Okay. What I'm used to is, um, I guess this, like selecting and dragging, um, whereas this move thing is similar to, it's similar to Blender's workflow, which is actually great because I can have my mouse anywhere in the screen, but as long as the node is selected and I'm in the move tool, or in move mode, I can just click anywhere and do this. Actually, wait, it mentions something here. Click and drag anywhere in the viewport and move it to the center of the view delimited by the rectangle. Uh, this. I think I've mentioned this on stream before. I don't remember if I have. There's a rectangle here. I believe this is supposed to, um, I believe this is supposed to represent our screen bounds. So anything outside of this might not appear in, like when you're in play mode, when you're playing the scene. I think so. I don't remember. We can test this out. I actually don't remember if we even need a camera 2D or not. In 3D mode, we do need a camera 3D. I don't remember if in 2D we require a camera 2D. I did add one, um, just in case it was required, but I haven't tested to see if it works without the thing, as in if the scene displays, uh, you know, stuff without a camera 2D. Okay, running the scene. Everything's ready to run. Everything's ready to run the scene. Press the Run Current Scene button in the top right corner, in the top right of the screen, or press F6. A pop-up invites you to save the scene, which is required to run it. Click the Save button in the file browser to save it as label dot, hold on. Okay, yeah, save it as label.tscn. Great, saved, and I was right. Okay, so this represents our screen bounds, and we don't actually need a camera 2D, which is interesting because I need to. Oh, let's exit. Hold on, let's exit the play mode because that starts consuming CPU resources, and my fan. I don't know if that just came through on the mic. My fan just became like really loud. Okay. Anyways, um, the save scene as dialog, like other file dialogues in the editor, only allows you to save files inside the project. The res path at the top of the window represents the project's root directory. Oh, that's what you mean by inside the project. So within the root directory. Okay, so it represents the project's root directory and stands for resource path. For more information about the file paths, I definitely want to learn about this. Yes, I'm going to open this up, and it's either going to be on stream or off stream. Like maybe we can dedicate an entire stream to learning, that, because there are certain file system related specifics that I need to know, that I need to learn about when it comes to Godot. First of all, just generally doing file system stuff in Godot. I want to learn how Godot handles um, the file structure and how it handles, let's say, finding assets or where certain files are stored and stuff. How it's reading, how basically how it's managing that entire asset structure, that entire directory structure, that entire like directory structure containing all of the things. I'm not even sure what terms to use here. Basically, your entire project structure. I'm just going to say that. How Godot handles your entire project structure. That is, including your saved scenes, your any extra assets, like, I don't know, sprites and audio files and all like resources. Okay, the application should open in a new window and display the text "Hello World." Okay, close the window or press F8 to quit the running scene. Setting the main scene. Run our test scene. To run our test scene, we use the Run Current Scene button. Another button next to it, Run Project, allows you to set and run the project's main source, the project's main scene. You can also press F5 to do so. Running the project's main scene is distinct from running the current scene. This is actually something that tripped me up before. In one of the previous streams, towards the end, we had this issue where I'd set up the scene. It was a Node 2D scene. So the root node was a Node 2D. And what I wanted to test out was whether 2D and 3D render together and like what that entire thing looks like. Um, and what was I saying? Sorry, zoned out. What was I saying? I was trying to set up a simple scene with 2D and 3D nodes to see how that gets rendered. This was, I believe, at the time when we were learning about how 2D and 3D is handled in Godot. And holy shit, I'm glad that I took the time to do that research because, yo, doing that research and experimenting and stuff, it cleared up a lot for me. It cleared up a lot of stuff that I didn't understand about how the rendering is done, especially coming from Unity, where the rendering gets handled in a very different way, or at least used to. Now, at this point, like I don't know how the rendering is being handled, especially considering that they've made the scriptable render pipelines the default. So like I can't say anything about how rendering gets handled there. But yeah, yeah. Okay. Uh, Running so and so is different from so and so. If you encounter unexpected, yeah. Okay. Back to what I was saying about what tripped me up the last time and why we were having issues getting the scene to display anything. The reason for that was that I was running a different scene. So like this main scene that we can set, this I'd set it initially to some other empty node 2D scene, and I was trying to run a different scene. I was I was not trying to run that empty scene. I was trying to run this scene in which I'd added a sprite 2D and a camera 2D and a mesh instance 3D and a camera 3D. I was trying to run this scene, but when I hit F5, not knowing that it was actually running the main scene and not the current scene, it tried to run that other scene, that main scene, which was just empty. It didn't have anything in it. So then later on, I did some research and I found out that I was supposed to be hitting, I was supposed to hit F6, not F5. Okay, back to this. If you encounter unexpected behavior, check to ensure you are running the correct scene. Okay, yeah. So I'm curious about something right now because that scene that I was just talking about, that empty scene, I deleted that earlier, and that scene is what was set as the main scene. I should see how to change. I'm sure there's some place that I can go and check what the quote unquote main scene is. But yeah, I'm curious about what's gonna. Oh, that just got cleaned up. Okay. So because I deleted that node and that node was set as, or because I deleted that scene and that scene was set as the main scene, so now the main scene is nothing. So the editor cleaned that up. Good to know. No main scene has ever been defined. Select one. You can change it later in, okay, there it is, project settings. That's where we can go to check what the main scene is. Um, project settings under the application category. All right. Yeah, select the current one. And this is our scene. Great. Okay, click the select button. Oh, this is showing the dialog that pops up. Oh, we could have done that. We could have, well, that's okay. Um, even if the dialogue would have popped up, you guys wouldn't have seen it on stream. So, I mean, I've seen the dialogue before, so it's okay. There's nothing to be excited about there. Okay, the demo should run again. Moving forward, hold on, let me close this because my fans are getting louder. Okay, moving forward, every time you run the project, Godot will use this scene as a starting point. Note, the editor saves the main scene's path in a project.godot file in your project's directory. That's interesting because if if file system is supposed to show or if res is supposed to represent the wait, change split mode. Oh, I didn't know this was an option. Okay. Yeah, I should play around with this to see which one I like more. Okay, okay. What was I saying? Yeah, so if res is supposed to represent the project's root directory and these kinds of files, like the project settings file, what is this file called? Okay, something like this project.godot file. If this is also within the root directory, how is it that it's not popping up here? Is there some setting that I have to do to show those specific files? Because I'm assuming what it's going to be showing here is more stuff that can be used as assets and not stuff that is like settings related. So something related to the editor settings itself, or settings for this project that are supposed to apply to the editor, that are supposed to be used by the editor. I'm assuming it's not going to show that, though I could be wrong. Yeah, I need to check like what's the what's the situation there, how it handles that. Okay, while you can edit this text file directly to change project settings, you can also use the project settings window to do so. For more information, see project settings. Okay, in the next part, we will discuss another key concept in games and in Godot, creating instances of a scene. Okay, all right. Um, so here's what we're gonna do. I'm gonna end here. I'm not gonna read this next part, which is creating. I can load it up and then read it the next time. But yeah, we're not gonna like cover this entire thing now. We will cover this in the next stream. Hopefully, I'm able to start the stream on time and not not be so late, and then we'll be able to stream longer. And so hopefully in the next stream, we're able to finish this entire thing, this entire creating instances thing, and maybe even the scripting languages page. Maybe we might be able to finish that as well. Um, there is this. Let's see how big this is. Yeah, scripting languages is not that big. It's just gonna give us a rundown of the different languages supported and what the pros and cons are, or what the specific features are there. Not even specific features. It's more pros and cons. It's like you can choose one over the other, and what's going to be different when you choose one over the other. So it's just explaining that kind of stuff. So yeah, we might be able to finish this as well, uh, along with this. We might, who knows, we might finish both of these pages tomorrow. Um, yeah, yeah. So that's gonna be it for today's stream. I'm wondering if I should raid someone today. I think I can raid. You know what? I think I can raid. It's a bit of a short stream, but that's okay. I'll raid. Uh, Give me a second. Let's do this. Getting stuff done. Let's body double. Okay. Co-working and studying. I like that name. This person's name is Corset1. I like that. Okay, what else? Television retro. Study and chat. Hey, you know what? No, okay. Here's what wait, what is this? Spring is so close. Spring is so close I can taste the tequila. That's crazy. Okay, okay. Um, now you know what we're gonna do? We are gonna raid Louise McJagger. Louise is cool people. Louise is I don't want that music coming through on my stream. Louise is cool people. Louise is super chill. I don't know what is her timer at. She's got like 12 minutes remaining, and then we'll be able to chat with her. She's definitely gonna chat once we like raid in, and then she's gonna get back to her thing. But yeah, Louise is cool. We're gonna go hang out in her stream, and yeah, that's gonna be it for today's stream. We made some good progress today. Hopefully tomorrow we'll be able to finish this entire page, and maybe even this entire page. And then the exciting part comes in, which is actually scripting, actually creating a script. Okay, my fans are going crazy now. My computer's fans. So I'm gonna end the well, I'm gonna let the raid go through. So that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next